I'm going to let x be equal to my loss amount, and I'll let y denote the payment. We want to find the variance of y. Well, first let's find the first and second moments of y. What is the expected value of y? There are a couple ways that we could do this. One is, I understand the distribution of x, so I'll begin by doing everything in terms of x. So I'll do some sort of integral of the density with respect to x. What's the density of my loss amount? It's 1/6 because it's uniformly distributed between 0 and 6. When I make a payment, I make a payment if the loss amount is at least 2 and at most 6. And how much is my payment amount going to be? It's going to be x minus 2 if the loss is 2 or more. By change of variables, we can rewrite this as an integral from 0 to 4 of u times 1/6 integrated du, where u is equal to x minus 2. What is that integral going to be? That integral is going to be u squared over 2 times 1/6. So I get 1/6 times u squared over 2 is going to be 1/2. Evaluated from 0 to 4 gives me a 4 squared. 4 squared over 2 is going to be 16 over 2, or just 8. So I get 8 divided by 6, or 4/3. There's actually a shorter way we could have done this. Another way that we could have done this problem is I could have said the expected value of y is going to be 0 times the probability x is less than 2. Or, on the other hand, it's going to be the expected value of x minus 2 conditioned to x being greater than 2 times the probability that x is greater than 2. The first term gives me 0. The second term, x minus 2 is just x shifted over. It's still going to be uniform. Conditioned on x being greater than 2, that's a uniform random variable. That's going to be uniform between 0 and 4. X minus 2 is uniform between 2 and 6. I'm just moving it down to 0 to 4. So that's going to have mean 2. The probability of x being greater than 2 is 4/6, or 2/3. And so once again, I get 4/3. So that's the first moment of my y. What about the second moment? Well, the expected value of y squared, we can do it in either one of these ways. I could have just done an integral from 2 to 6 of x minus 2 squared times 1/6 integrated dx. Or I could do it the same way I did it, sort of my shortcut here, the second way. I could say that this is going to be 0 times the probability x is less than 2 plus the second moment of x minus 2 conditioned to x being greater than 2 times the probability that x is greater than 2. What is my first term? My first term is 0 because it's 0 times whatever. The second thing, x minus 2 conditioned to x being greater than 2 is uniform between 0 and 4. So I want the second moment of a uniform random variable. What's the second moment of that uniform random variable? It's going to be the mean squared plus its variance. The variance is 1/12 of the range of that variable squared. What's the probability x is greater than 2? Once again, it's going to be equal to 2/3. So what is that term going to give me? That ends up giving me 32/9. So what is going to be the variance of y? The variance of y is going to be the second moment, 32/9, minus the first moment, 4/3 squared. 4/3 squared is going to be 16/9, so 32 minus 16 gives me 16/9. And my answer is answer choice D.